Okay, this is going to be an interesting lecture for you. Okay, the first thing you will notice is when you've opened today's announcement, there's a cornucopia of lectures, all with my face on them. Okay, what I have done, and you'll see under the list, previous lectures. Last year when I was doing, when we had more time in class, I had pretty much one lecture for the week on this, and I spent more time talking about each item. So if you're having trouble understanding some of the terms, go back to the particular one you're looking for. We are in this order. The first one is on prisms. The second one is on pyramids. The third is on cylinders. The fourth is on cones. The fifth is on spheres. I'm going to go over all of those today, and you're going to be able to look at them and go, I get that, I have no idea what he's talking about there. You're going to have very few problems on this, and there's only going to be a few problems on the final exam for it, so don't worry a ton. But this is important for you to at least understand or see, so when you get later on in math, you'll have an idea, say, oh yeah, I remember a little bit about that. Could you refresh us? And the other math teachers will know, because we're sitting down at the end of the year to say, hey, I was able to cover this, I didn't get this. Okay, so the algebra teachers aren't getting some things, I'll pick that up at the beginning of the year. I'm not going to get to some things, the algebra 2 teachers will pick it up at the beginning of the year. Don't worry, you will get what you need. Okay? Understand that a three-dimensional solid, okay, is what we deal with all the time. There is, okay, a cube is probably the most basic of three-dimensional objects. Okay, it's got length, it's got width, it's got height. Okay, now what I want you to understand, because all of these items deal with it. Okay, and this one, on a cube, everything is a square, very easy to deal with. Okay, you're also going to see rectangles. You're going to see triangular prisms, which I'll show you in a second. Okay, there's going to be pyramids, cylinders, which are just cans, cones, which we eat ice cream out of, one of the most important inventions of all time. Okay, and spheres, which are essentially a basketball, a baseball, a softball, a soccer ball. It's a ball. Okay, so here we go, some terms. Where two faces come together is an edge. Okay, the sides are called faces. They have areas. Those are two-dimensionals. We've dealt with those. Okay, the top and the bottom, okay, they may be on their side, but those are called bases. Now, on a cube, it doesn't really matter because they're all the same. But on the other figures, it will. Okay, so you have three types of measure. You have linear measure, which we talked about. Okay, the height. Okay, that's like 4 inches. Okay, the width, about the same. Okay, those are linear measures. You have two-dimensional, or areas. Okay, 4 times 4, 16 square inches. Okay, and in this particular case, 4 times 4 times 4 is 64 cubic inches. Okay? Cube. A cube is how we measure volume. How many cubes can you stack in a room, for example? Okay? The size of the cube is going to matter because the larger the object. In a room, we could probably use square feet. So if you took each of these tiles on the floor and built a cube out of it and stacked them, that's the volume. Okay? If it's a very large area, like a tanker ship, you'd probably use, cubic yards or something along those lines. Okay? So that's what the three types of measures are that we're going to deal with. The first lecture today deals with the two-dimensional, or surface area and lateral area. Lateral area is the sum of the side areas, and the surface area adds in the top and the bottom. A surface area, think about it this way. If I'm wrapping Christmas gifts, How much wrapping paper would it take to cover this? That's the surface area. How much paint would it take to cover this? That's the surface area. Okay? So that's what we look at. When we find a surface area, we start by finding the lateral area and then adding the bases. Okay? If it's a prism or a cylinder, there's a top and a bottom. So there's two bases. If it's a pyramid or a cone, there's one base. Okay? If it's a sphere, there ain't no bases. Otherwise, it wouldn't bounce and roll. Come on, people, think about it. Okay? So here we go. Here's the terms. And you'll find on the notes, okay, I'll put all the resources up at the last, on the end of it, and go over them with you, because the notes I have in there, all of these formulas are in there. All of the terminology is at the beginning of it. Okay, so it's a good resource on this one. Okay, and the PowerPoints, they're there as well. This textbook uses a little different terminology when it gets to spheres, but all of the other terminology is the same. A right prism means that the vertical edges and the lengths are perpendicular. Okay, an oblique prism is leaning, like the Leaning Tower of Pisa. We could still find lateral area and volume from it, okay, just like we did with an obtuse triangle. We're not, however. We're going to deal with right prisms. Okay? There's a length, a width, and a height. This would be a rectangular solid. It's a rectangular solid because the bases are rectangles. That's how they're named. Clever, huh? This is a triangular solid. Do not be fooled here. Okay? The triangles are the bases. The height is the distance between the bases. Okay? When we go through the examples, you'll see some of those. Okay? When we look at a lateral area, we say length times height, width times height, the back length times... It's easier just to say the perimeter of the base times the height. That's the lateral area. Okay? It works the same way as if you opened this all up and added all the rectangles together. Okay? So, the surface area, since there are two bases here, the surface area, we take the perimeter of the base, multiply it by the height. There's your lateral area. To that we add, since there's two bases, 2 times the area of the base. Okay? I would probably write these down for use on a test or final. Just me. Okay? A pyramid. Now, a pyramid, the faces, the sides going around, those are all triangles. So we have 2 different heights. Remember, on a triangle, we got base times height for the area, but you've also got the height or altitude of the pyramid itself. It's like standing at the top of one of the great pyramids in Egypt, sliding that rock away, and before the Egyptian police can come and take your butt away to jail, you drop a rope down in there and you say, I'm going to get some treasure. No, you're not. You're going to jail. Okay? But that height is the one that goes straight down to the base. Okay? That's the actual height of the pyramid or altitude of the pyramid. The slant height, which is used, we use the letter L for, okay? That's the one, so when you're trying to get away from the police, you take that rope and you throw it down the side of the pyramid and you rappel down. That's the slant height because it's slanted. So what you're doing on a pyramid is finding the area of the pyramids going around, adding them together, and then adding the base. So, because a triangle's area formula is 1/2 base height, 1/2, that's part, okay, that's part of the perimeter, and that height, the slant height. Okay, so there's your lateral area, plus the area of the one base. Okay? And once again, pyramids are named by their base. I like to stay with square base pyramids. On our assignment, you may get a rectangle in there, okay? And if you get the height and a slant height, you're going to be able to create a right triangle in there. We'll have to do that, okay? We're going to be dealing with the Pythagorean theorem. Cylinders, cans. You go into the cupboard, you're probably going to find a soup can, okay? Cylinders are easy. There's only 2 measures. There's a height, okay, and a radius. The circles on the top and the bottom are the same, okay? So instead of having to deal with, oh God, I've got a triangle formula for a base, I've got a rectangle, a square. Area of a circle is the area of a circle, pi r squared. Circumference, 2 pi r. They're not going to change, okay? So the cylinder and cones are much easier to deal with, okay? So we're going to say 2 pi r, okay, circumference, times the height, okay? That's just like saying perimeter times height. Same thing, okay? And we're going to add the area of the two bases, pi r squared plus pi r squared, okay? The cone, like the pyramid, only has one base, okay? The cone, because it's got a circle base, we only have to worry about 1 pi r squared. And then just like we said, half the perimeter times the slant height, half of 2 pi r is just pi r, okay? So we're going to say pi times the radius times the slant height. That's the lateral area, and we add to it the one circle on the bottom, okay? Spheres, I'm going to put all together at the end, okay? So these are the lateral and surface areas for our figures, okay? There are two different types of areas. Remember, there's the lateral and the surface. On a sphere, there's only surface, okay? There's no top and bottom, okay? So let's go over and work on some of our figures here, okay? Multiple colors. And let's go. We'll do the first 6, okay, figures here. And these 6 are going to be surface areas. Okay, they're just going to be surface areas. Okay? So, the first thing I'm going to look at is say, okay, what I want to do is say, what's the surface area for a cone? Okay, I checked my notes. Okay, so I know it's going to be pi times the radius times the slant height, okay, plus pi r squared. Well, it seems we're missing a slant height here, okay? So yeah, you've got a right triangle, and yeah, you're going to use the Pythagorean theorem, okay? 4 squared is 16, 5 squared is 25. This works out to be radical 41. Okay, that's your slant height. So we have pi 4 radical 41 pi 4 squared. Folks, if calculators were designed for anything, it's this. Okay? Plug these numbers in. This one is going to end up being 80.5. And that's how you're going to do that, and leave it there. Okay? Just leave it there. That's fine. Remember, if we're going exact answers, we leave pi in the answer. We leave radical 41. In this one, I don't think it's going to be any easier than saying, okay, 4 radical 41 pi plus 16 pi. You do it. That's how we leave it too. Okay? Let's come down here. Okay, on this one, yep, we're going to have to use the Pythagorean theorem again. We've got to find this right here, because we've got to be able to find the perimeter of the base. Okay, so the first thing we're going to do there is go, okay, that's going to be 8 squared is 64, 5 squared is 25. 64 and 25 is 89. Okay? Let's set it up. In this case, perimeter times height. 5 plus 8 plus radical 89. Now, our directions on the worksheet, like the ones you're going to be doing for assignment, say round to the nearest tenth. So we're going to take radical 89 and turn that into 9.43. Now we can figure out a perimeter. Our height is 10, okay? So we've also got to deal with one base here, one base back there. Okay, so the perimeter is 5 plus 8 plus 9, 4, 3, okay? And that's going to be times the 10, okay? That's going to end up being 2243 times 224. Okay, triangle, base, height. Okay, so 1/2 times base times height is 20. And there's two of them. Okay, and once again, time for the calculator. Okay. Okay, let's look here. We go to a pyramid now. On our pyramid, we are given the slant height. Okay, we're given a base inch. It's a square, look at that. Okay, we don't need to find the height because we're not finding the volume. Okay, so we are going to say for the pyramid, okay, so what we've got here, 9, 9, 9, and 9, perimeter's 36, slant height is 10, so 1/2 times 36 times 10, area of the square, 9 squared, okay, yeah, it looks a lot more confusing than it really is. The more you practice with these, once you plug it in, it's just plugging in numbers to your calculator is all it really is. Okay, now we've got another triangular prism. There's a 4, there's a 4, so that means this is also 4. Okay. So the perimeter is 4 plus 5 plus 4, and the height's 9.5. Okay. Now the area of the triangle, yeah, we got to do this because we got to find the area of a triangle. So this is 2.5 over here. This is where you're going to use the Pythagorean theorem again. A squared plus 2.5 squared equals 4 squared, and you're going to get about 3.1. Okay, since it says tenths, we'll stay with tenths. Okay, so 1/2 times 5 times 3.1. Okay, you're going to get 15.6 over here. That's going to be okay. Once again, your fingers are going to be more sore than your brain when you're done with this. I promise you. Okay. Cylinder. Cylinder's the quickest. Okay? Quick and easy. Okay. 2 pi r h. There's r, there's h. Area of the base, pi r squared. Just plug the numbers in. Okay? Then, once again, since our directions tell us to go to the 10th place, that means we're going to multiply by pi with our calculators. Okay, 3.14, or if you've got the pi symbol on one of your keys, use it. Makes life easier. Okay? Okay, once you do that, that's where it comes out. Finally, okay, a box, a rectangular solid. Okay, perimeter of the base, 12 plus 10 plus 12 plus 10, okay, times the height. Okay, so we've got that. So we're going to take 44 times 12. And the area of the rectangle is 12 times 10. Okay. And we're going to end, don't even have to do that one. Okay. So there's our first lecture, and that's with surface area. Okay? It's a little longer because I explained some terms. Okay? Tell you what I'm going to do. I'm just going to stop this one, okay, and create a second one for volume. Make it easier for you. And I'll also put the spheres on there too. Remember, we have nothing to sphere but sphere itself. Okay?